Thanks everybody for joining. I've been looking forward to this for a while. But let me start as a with an introduction. My name is Jad El-Zein, and I am a principal technologist at VMware by Broadcom. And I wrapped up my 16th year at VMware in December, so hoping to make it a good 17th. And what I've been focusing on lately has been platform engineering, which is very suitable for the conversation we're about to have. Now, I'll get this out of the way. What is VMware doing talking about platform engineering? Well, hopefully, I will answer that throughout this conversation. Maybe, you know, let you in on some of the work that has gotten us here, VMware's commitment to this area, but most importantly, we're going to talk about these five principles of modern apps, right? And I'm going to keep it subject specific and not necessarily, as I promised, not necessarily a pitch of any sort. Okay. So the agenda is incredibly straightforward. We've got just a couple of intro slides, and then we're going to just jump into the five principles of modern apps. Now, before I get into that, these five principles, they are not like set in stone. This is the only way to do this. But it's what's worked for a lot of the customers and partners that and cloud providers and such that I speak to. It's what we've gotten behind as an industry, and so we'll get a little bit into the weeds and the in those principles, right? The things we need to be successful or do to be successful. So, the reason platform engineering has become more and more important, and obviously you watch this channel, you follow platformengineering.org. Certainly, this is something that's on your mind a lot, I would expect. But we've gotten here because, software development and software delivery, as well as the infrastructure and the resources available to everybody, as well as the tools and CNCF and what everybody's doing, has evolved significantly, right? Okay. Okay. And the industry as a whole has continued to try to stay ahead of it. I wouldn't say even catch up, but try to stay ahead of it. But if we look back a little bit at the waterfall era, right, where requirements were defined up front, software was built and tested in sequential phases. I mean, that worked for a time, but it couldn't keep pace for the rising complexity of apps or systems or the needs or business, right? The demands by the users. But then came DevOps. Now, DevOps is, I mean, it's still something that everybody thinks about, maybe keeps you up at night. But DevOps is the big goal here was to break down the silos between development and operations, Dev and Ops. It introduced things like automation and continuous integration and delivery, and a culture of shared responsibility. And it was a huge leap forward from where we were in waterfall because the sequential thing didn't really work, but it largely operated within the constraints of traditional infrastructure, right? So as we evolved away from traditional infrastructure and into the cloud native era, we had to design for elasticity and scale and resilience from day one, from early code to delivery. And applications now are composed largely, new apps anyway, greenfield apps, or rebuilt apps, composed of microservices, right? They're built for Kubernetes. They're deployed with your GitOps practices. And it's not just faster, it's fundamentally more adaptive and adaptable across infrastructures, cloud providers, sovereign clouds, and this big shift we're seeing that we saw to the public cloud, but also now back into private cloud. So where waterfall was slow and fragile, cloud native is agile and self-healing, and it was a big push. And I put here, we are here, allegedly, we are here, and your position may vary. So the important takeaway here is that each step of this evolution and the continued evolution, it wasn't just changing tools, right? It was a shift in mindset. It was, from predictable release cycles to continuous integration and or innovation and integration, infrastructure management to platform engineering, right? And so the goal was to take these isolated teams to cross-functional collaboration, and it puts the developer experience up front, which is ultimately the goal for all of this, as well as platform engineering as a whole. Okay, so that's my opening setup, and I'm going to just talk a little bit about these five principles, and then we're gonna dig right into them. And I will run out of time so quickly, so I will try to get through this. Uh, so. These five principles, again, these seems to be what works. It seems to be what the industry agrees on, right? So you've got your cloud native, composable, API first infrastructure, and I'm going to spend the rest of the presentation really talking about these. So declarative, GitOps driven delivery and ops, observability and closed loop automation, and of course, everyone's favorite, zero trust security, your compliance and resilience by design. This isn't about build me an app, then secure it. This is build me a secure app. Very different. But anyway, we'll get into that. And then everybody's favorite, again, if you're here, platform engineering is probably on your mind, as it's been on mine and VMware's as a whole. And so platform engineering as a foundation. This isn't a destination. This isn't, hey, let's try to align with this. Platform engineering and what we're going to dig into is really about how to fundamentally think about the tools and services and capabilities and methodologies and people that are involved in your day-to-day app modernization journey. Okay. So to get us started, we've got cloud native composable API first architectures. So this gets us into a couple of some of the main components of the setting the foundation, right? The main components of platform engineering, or the IDP, right? So composability. Oh, I think I'm in the. Okay, here we are. There we go. So with composability, we are building with interchangeable blocks, right? So composability allows us to lifecycle one capability or service without redeploying the entire app and all of its dependencies, right? The goal here is to be able to build Lego blocks of application services, to isolate failures, to allow different versions of subcodes or subsystems into the broader application, and use the appropriate runtimes, and maybe build for multiple runtimes, and whatever makes sense for the business, right? And the ultimate goal here is that last bullet. So composability turns the platform into a programmable catalog. Okay. So if you start at the bottom of the list here, you've got your base services and infrastructure. Now these are going to be more static capabilities that exist in your environment. This is everything from your shared data services to physical infrastructure, CPU, memory, networks, your edge services, and so on. Moving up from there, you've got your reusable components. These are also composable all the way into your applications. And then feeding all of these, your data, your connectivity, your security. So all of these different pieces are essentially domains or areas of composable code or composable infrastructure that you could use to build your application. So when I want to build a specific application or a specific code, or we'll just call it app, modern app, making it composable allows me to then be able to be very flexible and agile when it comes to any one of those other more static components changing. So instead of having to rip out and replace huge swaths of code from my application, I'm just identifying the pieces that then need to be changed, and then I'm, replacing just that component or just that module, right? In this case, all right. So composability is designed to modularize your applications and your code to make it a lot more flexible and a lot more capable. Now, and of course, that comes hand in hand with the API first design. In fact, API first design is probably the first point that should have been made there. Um, Now, this is what makes composability reliable, right? You've got your dev teams that define the API spec or Kubernetes CRD, for example, and functional details that are for the respective services up front. So you have a set of APIs that everybody agrees on, your platform engineering team, your engineers, etc. And these are the services that I build my composable modules on top of, right? So each one of these is a contract, and each contract is then written for and integrated with those contracts. So we're not necessarily getting into the weeds of the particular service, like a database, for example, or the nuances of an implementation or anything like that. I have the APIs. Now, in the world of Kubernetes and in the world of microservices and such, that Kubernetes declarative API is really my go-to. It's where I want to go. Okay. Now for VCF, I said I'm not going to spend too much time on it. We have a bunch of different areas in which the private cloud can be defined. So we don't necessarily just want to build these services to build new apps, but we extend this concept into building the infrastructure itself, so that when I'm provisioning or deploying entire clouds and entire platforms, I want to be able to leverage these similar constructs, capabilities, and so on. So the APIs and how we use YAML from our automation tools in VMware Cloud Foundation, our adoption of open source and well-known tools such as Terraform from Hashi and then of course the Kubernetes API and declarative infrastructure. This is where we try to spend as much time making sure that our platform is as composable and aligns with these concepts as possible. And then once you've built the platform, you are then building apps and services on top of that using the same exact APIs, right? If that makes sense. So from a platform perspective, VMware Cloud Foundation, aligns with the API first model and by exposing the unique services via API-based interfaces, your CLIs, your UIs, and so on. And then we invoke them to integrate the many moving parts of the broader platform. So it comes together as a whole. So we're eating our own dog food, drinking our own champagne, I don't know, tasting our own chocolate, whatever works for you. But so that means like the same concepts I have for in CI/CD and GitOps tooling and so on used for application code can programmatically provision entire workload domains, entire private cloud infrastructures, not to repeat myself here, right? Your storage, your blueprints, and so on. Okay. So from a composability perspective, API first perspective, I think we kind of laying down the basics. And again, I probably have to move a little bit faster here. But that takes us to the next piece that it's going to rely on heavily on the API, and that's declarative GitOps driven delivery. So now over the last 4 or 5 years, the industry as a whole has largely settled on declarative configuration and usually continuous reconciliation as the baseline for provisioning and lifecycling, especially modern applications, right? And it's that commonality or that baseline that spawned GitOps, right? Git and Ops. And CNCF has an open GitOps initiative, and they call out 4 core principles, right? Declarative. as we've covered, versioned and immutable, pulled automatically, right? And continuously reconciled. Now, a lot of folks would suggest they follow all these GitOps processes with not necessarily doing it to the T, but hey, whatever floats your boat, it doesn't necessarily matter. You following the processes that gets you partly there, then you're on your way to gaining the benefits of a fully a fully composable API driven, GitOps driven delivery and ops environment. But it's very important to understand that you have to take these in strides, right? We can't just jump in and say, okay, from now on, everything is going to be following, these GitOps principles. So, the takeaway, as you adopt GitOps methodology, you get measurable benefits. It's first of all, it's reproducible, right? You've got reproducible environments. You've got simpler rollbacks. You have full change audit history. So as things are done, you're auditing every step of the way. So if a mistake is made, I've got full understanding of what's happened and how to roll it back, right? It almost writes its own recovery plan or run book, right? And it's a natural integration for policy as code or anything as code, infra as code, policy as code, just to name a few. So the bonus outcome for regulated environments, again, I mentioned I was out of DC. A huge part of my career was in the federal government and DoD. And a huge part of that was regulated environments, compliance, and so on, right? But one of the big requirements out of those environments is auditability. Who did what, why, were they allowed to, or obviously being able to use the understanding of what's happening in the environment to then build policies. So when you add GitOps practices with DevSecOps practices, you come together and you've pulled a pretty great environment. Okay. So now, looking at this might be a little bit repetitive here, but if you start considering like where these practices are best used, a classic example is a banking app or a finance app running on Kubernetes in multiple regions, right? Or any app really across multiple regions, which is pretty typical, especially in some of those pillars, right, of industry pillars. So all your Kubernetes objects, your network policies, even some cloud side native resources, they're all declared and stored in the Git repo of your choice, right? You've got new code promotions that are flowing from development to staging to prod via pull requests, for example. And the GitOps controller, in this case, and in VMware's case, we certainly highlight Argo CD. It continuously applies these changes and reports any configuration drift back into the platform. And so this is a perfect example of using rapid code development, rapid code changes and versioning and so on to continuously innovate and continuously push updates into a live production app or at least into the various stages of the app before it goes into production. So test dev and so on. Okay. So Argo CD is going to be a big player in this area, especially when we talk about VMware Cloud Foundation. It's a big part of our GitOps strategy. We're big believers in Argo CD and how it fits in the ecosystem. We've done a lot of integrations with it into our native tools as well, and into our Kubernetes platform. So lots of good things coming out of there. And then if you just look at it, a larger view on top of VMware Cloud Foundation, you've got your repos, your manifests, your pipelines, and so on. It all feeds various parts of the ecosystem, whether that's native VCF capabilities or part of our broader conformant community. VCF is designed to integrate with all these different tools, to get you to achieve your GitOps processes without necessarily having to rip and replace your tools. Now that's the other part of it, right? So VCF 9, which was the latest version, it's essentially a GitOps playground for private cloud, if I can say so. Because I mean, we provide the unified consumption interface. It allows developers and platform engineers alike to hit single endpoints when consuming, managing, operating the cloud and their applications. Everything is infra as code. Also expose your good old REST APIs and allowing platform engineers, infrastructure admins, cloud admins, and developers alike to use common code to stand up everything from physical infrastructure and workload domains to database stacks to private AI services, right? And so with these services, these are designed to really help accelerate the adoption of GitOps, but not force your hand into doing that, but provide the ability to at least be that foundation to do all of those things, including networking and storage and so on. All right. So moving on, just quick time check. Okay. Observability. Now, this is a favorite one of mine because I think observability started to be used just like tissue or Kleenex is used to describe tissues. Everybody has observability. But we need to understand the difference between observability and things like operations. Metrics alone, for example, aren't observability. Um, I'm just metrics, for example. But once you start getting into, these modern apps, for example, the feeds and speeds coming into an observability engine or any platform for the purpose of observability starts to get a little bit ridiculous, right? So apps and their respective infrastructure services are going to continuously generate just vast amounts of diverse telemetry data, metrics, logs, traces, events, and alerts, all of which have to be collected, correlated, and translated into usable data or usable information, actionable information. Once you do that, you've got observability. But you also have to be able to do it at a pretty finite level with some level of granularity, not like, you know, once every 10 minutes, let me see what's going on. This has to be almost constantly streaming. And so the ability to collect all of that data, then analyze it and make some sense into it, and of course tie that to KPIs and SLOs and everything else. That's where the magic happens. And in fact, I would say you can't necessarily run a modern private cloud or app shop without some level of observability today. Otherwise, you are missing some very important, likely missing some very important pieces. So, telemetry data should be used in a very systematic way, and you want to use that to drive decisions, not just debugging. This isn't. You don't want to know like, hey, what happened? You want to know what's about to happen, and that's how we're gonna get there. We also want to tie that to our service level or SLOs, service level objectives, and how all that telemetry translates to things that business really cares about, the people paying the money, right? And instead of saying like, oh, CPU's been high all week for this stack of infrastructure, or we're seeing latency to the edge. SLOs define user-centric objectives, like 99.9% of account inquiries have to be completed in some 500 milliseconds or less, right? Or not, right? So SLOs tie or they determine an allowable tolerance for failure while still meeting expectations. And the way I can measure that tolerance and measure whether or not I'm hitting those SLOs is, of course, back to observability. Okay. So feeds and speeds coming from all over the place, and this is probably not even holistic list. As everybody knows, your unique needs for your unique environments. But we do know that everything from underlying infrastructure all the way to the app and the microservices and the individual bits and pieces of all of that are going to each contribute vast amounts of data. Making sense of it is what observability is. Now, the other thing is um, you have to treat your telemetry data in these, you know, in these GitOps practices as an application itself. That's what I was trying to say. So if you start looking at like metrics and pipelines and dashboards and alert rules, your SLO definitions and your run books, all of those things can be defined as code and live in the same Git repos as your composable infrastructure does, right? Your manifests and blueprints. So the reason why we do this is so we could respond quickly to SLO misses, right? If I have a threshold in my SLO and I continuously miss that threshold, I need to be able to understand why I'm missing that threshold. And it might not be because I have constant failures. It might be that my threshold was not correctly set. In latency, for example, you can't just blindly say under 5 milliseconds latency when you now have an application that will never go under 10 milliseconds, but your SLOs are going through the roof. So building all of this as code, right? And using and configuring your telemetry collectors, your Prometheus, your OTel agents, and so on. And you're wiring all of these into your clusters and VM workloads. The idea is to have these configured these SLOs as desired state or as code or composable or any of the things I had just mentioned, so that you can rapidly evolve and rapidly respond to environmental telemetry. That way, that once your data is coming in, your telemetry is coming out, and you have all of that observed data and it constantly going in a closed loop, you're constantly tuning the environment for what suits you. Now, you could also say, well, I'm going to tune my environment to make sure I hit my SLOs. That's not necessarily the way it works. SLOs are also a contract with the business, and what your goal should be with closed loop telemetry collection is to constantly fine tune and preferably improve your posture from an SLO perspective. Cool. And then, of course, VCF. For if anybody familiar with previous versions or non-VCF 9 versions of our tools, there's been vast innovations with the most recent drop of VCF 9, which actually dropped last year. And it brings a lot of the different pieces of the VMware Cloud Foundation or the VMware portfolio. It brings the whole portfolio together into the VMware Cloud Foundation. And so where we used to have, operations doing operations and workflow optimization and troubleshooting and alerting, all that. And then we'd have, our networking observability tools doing networks and our logging doing logs and trying to piece all of this together through API. I wouldn't even call it integration, but communication. That was the thing. VCF 9 has done what I've been wanting to see since I started VMware 16 years ago, which is just actually bring all of these things together. So the state of any one component is understood by the rest of the components. And so observability is a huge example in this because I have all the disparate parts, right? I can see end to end of my whole environment from edge to physical infrastructure to individual services running in an individual cluster or node. Now I can correlate all of that because these tools have finally all come together. They've melded together. So observability in VCF has come a long way. Tons of data out there. Highly recommend you take a look. Again, I'm not here to sell you anything. I'm here to just share my experiences and propose you take a look, right? And with this big shift from VMware into Kubernetes and container runtimes and so on, what's actually been happening for many years now, 8+ years, observability has to also adapt. Our idea of observability, our tools have to adapt to take you into the individual microservices that run in these environments. So as we build out our Kubernetes runtime and the platform and the broader IDP, the tools continue to evolve to provide this level of observability. Now, one thing I guess I'm failing to mention is that no one platform will say, "Hey, this is the platform that's going to do all of these things for you." If so, you're being sold something. Um, but the ability to plug into the ecosystem, right? Be fully committed to CNCF and that whole community and the ecosystem, I think is what differentiates a platform that suggests it can do everything on its own versus a platform that truly can deliver the needs of all the personas involved in building and managing and operating clouds. So that is the path VMware has taken, especially in the last couple of years. I've never seen a an investment in the open source community as we've have at least in a couple of years. So that's been good. All right, so now let's shift a little bit to zero trust security. Again, here's one of those buzzword bingos that have just been overly used and abused. I'm gonna try to simplify it probably too much, but zero trust in a modern app context starts from a blatant assumption, right? Nothing is trusted just because where it exists or how it got there. Even if you built it, it doesn't matter. It's not trusted. So not the code, not the pod, not the node, not the network or volume or the user. So every request must be explicitly authenticated, authorized, and inspected. And that's the static posture. And then all the lateral movement must be tightly constrained. There's this old, hard shell, gooey middle, the egg analogy for microsegmentation and segmentation of workloads. That still applies today, right? That lateral movement is the killer. So I can block, I could have multi-tier firewall from my edge to my Tor to my edge to my core infrastructure. But if I get in one way or another, that lateral movement, that's what's going to get you. Okay. So in microservices architectures, the real perimeter is the workload itself. And that zero trust is implemented through layers of identity and policy and continuous verification, not a single magical, we can do it all firewall, right? In practice, that means workload level identity, strong auth at every hop, granular network segmentation, and microsegmentation, and aggressive least privilege for your pods, your service accounts, your Git access, your your declarative code, all of that. Okay. It's multiple levels. Now, I put this slide up because this is what we think, right? We think like, oh, I've segmented the heck out of my environment. I've got zones all laid out. I've got, I've got VLANs, VLANs, and I'm going to drop different apps and different VLANs, and then you bring in your Kubernetes infrastructure, and you've got all your tiers of networking happening there. You're SNATing this and DNATing that, and you think you're good. But the reality is what's happening on the right here is that the code is just laterally communicating. And it got there because it didn't work at first and you started poking holes everywhere, but still, called it secure. And so we need proof. We need to know that what I'm actually suggesting is secure is actually secure. And zero trust is how we get there. The actual zero trust, right? So here's my one slider, VCF 9, and through the use of a various set of tools, but let's just call it the platform as a whole. It it truly is a comprehensive security stack for zero trust implementation, right? At the network layer, with the integrated NSX capabilities, all the way into the hypervisor and all the isolation that we do at the VM level, right? Distributed firewalls with vDefend and some of the complementary tools with VCF. So we have lateral movement protection, but down to the per VM, per VNIC granularity, and IDS and IPS, malware prevention, all those things to enforce zero trust policies, especially around east-west traffic. So the distributed firewall is the thing here, right? So you could have VMs and containers and Kubernetes clusters and services spread all over your infrastructure on the same VLAN or different VLAN or many VLANs and isolation zones. It doesn't matter. Once you've protected all of those other things, only then can you suggest you have zero trust, right? So VPCs are a new construct in VCF. So you can carve out, isolated, multi-tenanted networks with custom routing and security policies and so on. So it takes this concept and also allows the platform engineer to do a lot more on their own, whereas CISO or your InfoSec teams would normally be involved. So again, everything defined as code, new boundaries, application level boundaries, and so on. So vDefend is what I'm talking about here. So to learn more about vDefend, please do search it up. And there's a lot happening in this area. So do keep your eyes peeled, ears peeled. All right. So all of those things get us to platform engineering. Now, the funny thing is, this is one of those five key principles. Platform engineering itself is a principle of for modern apps, and in fact, it's the most important one, right? So, platform engineering, in my opinion, stands out as the most transformative, for an organization or a business or an enterprise building and managing modern apps, right? But also existing virtual machine-based apps, public clouds, and so on, right? So platform engineering it's a discipline. I feel weird describing this on a platformengineering.org webinar, but platform engineering is the discipline of designing and building tool chains and workflows that enable self-service and some level of developer autonomy for developers, right? And in some sense, platform engineering is the evolution or a result of traditional DevOps. I'm not sure if you guys agree with that, but I do think that it is the evolution of DevOps and what it used to be, because we're moving from abstract methodologies to a more concrete deliverable, and such as laying the groundwork for the platform engineering deliverable, which is the IDP. Okay, so the IDP is the internal developer platform, right? And what we want to do with that, it's okay. So the platform engineering, as we all know and can hopefully all agree, is it's not to create new barriers or infrastructure barriers or return to the days of rigid IT and no wild west and ops this and CISO that and so on. Really, it's designed to reduce the developer's cognitive load, right? And the burnout that's associated with that. And DevOps really did contribute, the DevOps methodologies really did contribute to those things, the burnout, from what, we've all probably experienced or heard anyway. And rather than expecting every developer to understand the unique intricacies of a particular app or infra or service or platform, your runtimes, your data services, your networking requirements and security, or anything else enterprise mandated, right? In order to run and build apps for that environment, the platform engineering team builds the IDP to provide, an agreed upon golden paths or paved road for consumption. Now, a golden path is an opinionated, governed, somewhat opinionated, governed, and automated workflow for building and deploying an application in a given environment, right? It's basically the template to stamp out apps and environments. So they're standardized routes to production, and they abstract all the underlying complexity while still providing the the desired developer autonomy. So done right, it really shouldn't matter what the underlying physical infrastructure is, VCF or not, right? Obviously. Platform engineering is designed to say like, hey, you come in, you're delivering the goods and the services. It just forget about all the noise, right? Forget about the calls to get certain services turned on or a load balancer or a VIP wired up or anything like that. It's supposed to do all of these things for you if the platform engineering team has done it right. And how it gets done is a back end detail that is accomplished through workflows and their own pipelines. So, this graphic just represents the reference architecture, a loose reference architecture of an IDP. And it's pretty generic, but I built it, and so I've positioned it best for VMware Cloud Foundation. But the primary goal of the stack is to abstract the complexity of the underlying infrastructure, right? It's how you get your golden paths. Now there's the IDP that the platform engineering team delivers as a product. It is their product, it is their deliverable. And that is a very important distinction because we want that product to be the best of its kind. We want to version it, we want to improve it, we want to innovate against it. So this feedback loop from developers and PEs is really designed to build better paths and to automate more and but also meeting the needs of the business, right? Now the platform engineering team has their own set of tools that they use to build these IDPs, and in fact, it's basically their own IDP. So from that perspective, you've got a much more infrastructure focused platform building stack, right? So your infrastructure and shared resources, which again are abstracted here, your platform services, and this is where the developer experience comes in. That whole developer experience is what matters for the developer and what matters for the PE delivering the service. Now, of course, we can't forget our governance and security and this feedback loop of like, okay, how do I do things better? How do I respond to incidents in this world? How do I manage capacity so that my SLAs and SLOs and metrics and telemetry and all these things all kind of evolve together, right? To be better together. Ultimately, the goal here is to deliver apps and have those apps be wholly reliable, as reliable as possible. So from a platform engineering perspective, here's your toolkit. This is these are the tools and services that you will use there to then take and build an IDP for the developer. Now, I stole a version of Platform Engineering's IDP map that we will be publishing also with PE. And for the developer, it's really a lot more software centric. So the infrastructure there is completely abstracted, right? What we care about are the main services that are going to be part of the overall IDP. Where this runs, how it runs, whether or not you're using a private cloud instantiation or shared cloud instantiation or public cloud or anything like that, where physical location of applications drop, all of that is noise. That's covered with the platform engineering's set of rules. Whereas IDP and the developers come in here, they're bringing their tool of choice, and this is just a snapshot of tools, and you can see in there I've got VCF peppered all over the place. But VCF's role in all of this is to really double down on this whole platform as a product thing, right? To make as much of this as seamlessly integrated or as a kind of the foundation of the IDPs is what VCF brings. So we've got all the infrastructure abstractions, but we've got all the services that can then be adopted programmatically. It can and included in your golden paths and paved roads and so on and so forth. So VCF really is set is the foundation, for lack of better words, to then build the rest of the IDP on top of that. And the way we accomplish that is to ensure that we're using that unified API for the entire platform so that your CNCF tool of choice can come right in, and we're not gonna worry about, do we integrate with this thing or that thing or that thing, right? This is all validated. The whole platform runs upstream conformant Kubernetes infrastructure. We're constantly updating the capabilities, and we're N plus 60 some days for adopting new Kubernetes versions, for example, all of which can then be brought into the IDP and made available as a service to my developers. So it is the fast start, but not the holistic. Never not yet anyway, would I suggest VCF is a holistic IDP. That's not what it's intended to be. For those of you aware of Tanzu, our sister company, Tanzu and VCF together, absolutely, we can build a turnkey solution that does end to end everything I've spoken about today. But we cannot be so ignorant that we cut out the roll your own tool gang and CNCF and all this other stuff. Those are such critical parts of GitOps and platform engineering and all of this that any platform needs to be fully aware and supportive of that ecosystem. Okay. All right. So I had just a couple more things here. One of the things that I have to mention on VCF, if you are not aware, is VCF as a platform not just builds and helps you build this ecosystem for platform engineering and developers through the IDP, but one of the big areas we've invested in is the runtime, right? So vSphere, the hypervisor itself, has been around for 2 decades now, right? And at some point, every enterprise in the world was running vSphere. And so over the last 8 years, what we've done is we've taken that strength and said, look, all workloads can run on this platform. So VKS came out of that. It was called other things before it became VKS with version 9, but the vSphere Kubernetes service, the VM service, the container as a service, all of these things are built into the platform with common, that leverage all your common underlying infrastructure and allows you to build any app on any runtime with any OS side by side directly in your vSphere clusters or your VCF environment. So that is where we've taken the platform. That is not a roadmap. And so, we've gotten behind this community. We're all in, I would say. In fact, being part of heavily committed to CNCF is also allowing us to invest more in events like KubeCon and other events like this, where we're VCF is very much committed to this community, into the needs of the community, and of course into the application builders out there building our next gen apps and AI agents. All right. So single platform, CNCF. I think I spoke ahead on this slide. CNCF upstream certified Kubernetes, 24-month support for a lot of the for VKS and the Kubernetes VKRs that the versions that we release and support. Big effort into integrating with the broader ecosystem, as I've mentioned many, many times already. And then, of course, the support of all of that is VMware Cloud Foundation behind you. And VMware, of course. So reach out to your favorite VMware team or reach out to me directly and we'll help you get there for sure. Okay. I know I'm way above time, way over time, but thank you all for your patience and your time. Whether you're listening live or playing it back, I really appreciate it. Yeah.
Thank you so much, Jed. A little bit over, but for good content, good
Yeah,
information, it's always worth waiting. So I've just got one question that I would jump into, and we'll just take a couple as they come in. But thank
sure.
you everyone so much for watching. Um, so from Charity, from your experience with high regulated environments, what are strategies and approaches for full circle automated deployments while ensuring compliance and such? Is it active policies, enforcement, approvals, or passive? Who did what, why, when?
Yeah, so really that's I mean that's an important question and a great one, but really it's a combination of the two. Here's the reality of today. If you're asking questions of how all your systems were hijacked and you have to pay some huge Bitcoin ransom, you've already messed up. It's already too late. You're done, right? So, the passive piece is important to help you kind of roll that back into future policy and future posture so that you're continuously following and hardening, right? And that works for those purposes. But still, as much as we want to say, as as a golden path is supposed to solve in these highly compliant verticals, including our own federal government and federal governments everywhere, banking and health and so on. There's still a lot of upfront governance that is going to be required, at least until the machines take over and we don't really have a choice. So active policies for certain, first line of defense. But the passive part is really designed to fix the active policies to make sure that they're doing their job. And that could be a slider in any direction. That could be to soften things a bit, to kind of lay off the governance, or it can be to harden based on real-time data being generated. I hope that answered your question, Jared.
Yeah, thank you very much. And I think with that, a huge thank you to everybody for joining. And thank you very much, Jed. This was awesome. And I think there's a fantastic article by you on platformengineering.org as well, if you want to read a little bit more about some of this stuff. And the recording is on YouTube right now, and you'll of course all receive the slides and a link to that tomorrow. So thank you so much, everybody, and thanks, Jed. And have a great evening, day, wherever you are. Bye, everybody.
Thanks all.